All right, so our last lesson is on matrix equations. So very similar to solving equations that you did in Algebra 1, but with matrices. And for these, whenever you see a variable, there's a matrix that goes there. So like this would be 4 times some 2 by 2 matrix is going to equal this one. And so if there's a 4 in front, 4 times something. Remember with scalar multiplication, we multiplied by 4 to get those inside numbers, right? So if we're doing the opposite, we're going to divide by 4. And so all we have to do is divide each of those 4 elements by 4. We divide by 4. We're just dividing all of the elements by 4. So you should get -9, -2, 0, 9. So just think of it like 4x equals -36. Think about what would you do if that was just a plain number there, not a matrix. And you're going to follow the same steps, at least for these first ones. So number 2, we have z plus a matrix. So how would I get z by itself? We're going to subtract the matrix. So we're going to subtract this matrix from both sides. Like those would cancel. Like if we had z plus 5 equals 7, okay, we would subtract 5. So z equals. So -7 minus -5 is what? -2. 7 minus 6, 1. -3 minus 4, -7. Looks like this next one, number 3, has a little bit more going on. So it might help. You don't have to write this. But let's just say I had 1 minus, can somebody open that? Okay. Just grab it. 1 minus 5a equals 6. What if this was just your equation? What step would you do first? We would subtract 1. That would be our first step, right? So our first step is going to be to subtract this matrix. So those would cancel, leaving us with -5a equals 6 minus 1 is 5. 0 minus 0 is 0. -7 minus 3 is -10. 10 minus 0 is 10. So then what do I do? Divide everything by -5. Good. We get -1, 0 to -2. So let's number 4. Go ahead and work on number 4. All right, so you are supposed to be working on number 4. So you should have added that matrix first and then divided by 4. Divided everything by 4 to get 2, -9, -1, and 8. Does anybody have any questions on this one? So if you'll look on these, every one that we've done so far, your variable has been right next to just a plain number or nothing at all. And those we can do a little easier. When we get to these others, your variable is next to an entire matrix. So if this was just a regular equation, 22 equals 5a, your instinct would be to divide by 5. But we don't do that. We don't just divide matrices. What we would do, if we were dividing by 5, that's the same thing as multiplying by 1/5. Those are reciprocals. So this is going to go back to inverses. So whenever your variable is with a matrix, you have to use the inverse. So we're not going to divide. What we're going to do is multiply by the inverse. So we first have to find the inverse of this matrix. If we want to get rid of it, that's the one that's with our variable. That's the one we have to get rid of. We have to find the inverse of it. So for the inverse, we have to first find the determinant. So we do 5 times 5, which is 25, minus 9 times 3, which is 27, and we get -2. So then for our inverse, we have 1 over -2. Now the 5s, those would switch places, but they're both 5, so it doesn't do anything. The 3 and the 9, they switch signs. And then we just distribute that -1/2, which essentially just makes that -2 become the denominator. You don't generally leave a negative in the denominator. That's why I wrote it up top. The same thing, really. Now, if we want to check to make sure we did it right, I'm going to type in the matrix. -2.5, that's -5/2. 1.5, 4.5, -2.5. So we did it correctly. Another thing that's important is thinking about the order that you do the multiplication in. Because remember, when we multiply matrices, it matters the order that you multiply them. So to get rid of this matrix, we want to put it in the front. Okay. That means I'm going to multiply it in the front on this side. So I'm going to multiply negative 5 halves, 3 halves, 9 halves, negative 5 halves by 22, negative 14, 36, and negative 26. For these, I'm okay with you just typing it in the calculator. You don't have to do this multiplication by hand. So we're going to type that in. And so then after I got that answer, I went back and plugged in this matrix times what I got for matrix A to verify that it was this 22, negative 14. And it was. So you don't want to do all of this work and then get the wrong answer. Okay, so it's good to check your answer to make sure that you did it correctly. So let's look at number 6. All right, so we have a matrix times x equals this one. Now let's think about this matrix. This is a 2 by 1 matrix. When I get the inverse, I'm going to have to get the inverse of the 2 by 2 because that's the one I need to get rid of. Okay, it's the one that's stuck to the x. My goal is to get x by itself. Where should I multiply it, before or after this one? It's a 2 by 2. It has to be before, right? So when we get our inverse, make sure that you do it before. You can't even do it after because those wouldn't work. So you have to do it before anyway. So we're going to start. We want to get rid of this entire matrix, so we have to find the inverse of it. So the determinant first, we have positive 25 minus, this is not a negative 8. That's just, if yours has that mark, that's just from the copier. 8 times 3 is 24. 25 minus 24 is 1. So then for the inverse, we have 1 over 1 times, okay. Once again, these, if we switch them, it doesn't change anything. The 3 and the 8 both become negative. And if I multiply by 1, that doesn't do anything. So we got to put it in the front. So whenever we multiply by our inverse, essentially those are going to cancel out. So you don't have to show that multiplication. That essentially cancels. But we do need to do this. Actually, I need to put x equals. And then we have our inverse. Times this one. So alpha zoom, put in the 2 by 2 first. Now be careful when you go to do your second one, it's a 2 by 1. If you mess up your dimensions, you got to retype the whole thing in. And if we want to check our answer, we can type in the original. So this original times x. We found that x was -5, -3. And it does equal 16, -25. All right, number 7. This one has it's a multi-step one. So what step do we do first? We're going to subtract this matrix first. Good. So those would cancel. -46 minus -11 is -35. And -10 minus 1 is -11. Oh, I forgot my x. So then we have a matrix times x. Can't divide by a matrix. We can only multiply by the inverse. So let's find the inverse. So the determinant, -1 times 1 is -1 minus -5, which is 4. And then for the inverse, we have to do 1 over 4 times this matrix. So our A and D switch places. So the 1 and the -1 switch places. These switch signs. So -5, +1. And then we distribute, so it becomes 1/4, -5/4, 1/4, -1/4. And that has to go in front. So when we multiply this matrix by its inverse, those cancel. I don't have room to rewrite it. So I'm just going to type in this inverse matrix times this one. And you don't have to, you can leave it, like you don't have to do the actual fraction button. You should get 5 negative 6. And if you wanted to check alpha zoom, we'll just go back to our original equation. And we did it correctly. Now, number 8 is a little bit more complicated. So we are going to subtract this matrix first. So I'm not going to write that out, okay, just to save some space. So if we subtract it, no, those will cancel. So negative 8 minus negative 1 is negative 7. Negative 35 minus negative 2, negative 35 minus negative 2 is negative 33. 1 minus negative 6 is positive 7. And 20 minus 8 is 12. Then what do you think I do? We're going to divide by negative 1. This is really like a negative 1 there. So we're going to divide everything by negative 1. So I want you to take it from this step and try to find y. And I would, if I were you, because this one's pretty complicated, I would definitely check your answer. I've messed up somewhere. Oh, I don't know what I did. See, if I would not have checked my answer, I would not have found my mistake. So you got to the spot where you had to find the inverse. So you should have been finding the inverse of the negative 1, 11, 1, negative 4. Because that's the one that you've got to get rid of. If there was just a number there, you would be dividing by that number. Like 2y equals 7, you would be dividing by 2. We don't divide by a matrix. We have to multiply by the inverse. Okay, so you should have found the inverse of that. And that would have given you y. Well, no. You found the inverse, and that had to be multiplied by the 733, negative 7, negative 12.
Oh, so you just multiply it at that point?
Mm-hmm. Okay. So, like, basically, like an equation, you have to do the same thing to both sides. So, technically, you would multiply the inverse by the negative 111, but those basically cancel out, leaving you with y equals, and then you multiply. But you have to put the inverse in the front. All right. So we stopped here. You found the inverse of this one. That was what I did. I wrote down the determinant was negative 7, but I wrote it down here as positive 7. And so I messed up all my signs. That's where my mistake was at first. So your inverse is 4 over 7, 11 over 7, 1 over 7, 1 over 7. Now that inverse, we multiply. Okay, when we multiply it here on the left, when you multiply an inverse, a matrix by its inverse, they cancel. So we multiplied this matrix by its inverse, that canceled, leaving y. And then here we multiply it by that. And you get negative 7, 0, 0, 3. So it's important what I did to check my answer. I went back and typed this in, but I filled in this matrix for y. And when I did it the first time, I did not get this. So I knew I'd messed up somewhere. And I found it there. Luckily, it was something small. So just to explain that a little further, if we have 2x plus 5 equals 19. You don't have to write this down, you can just watch. We would subtract 5, which I think you all are really good, like you know when to subtract the matrix first. And we get 2x equals 14. Typically, you would divide by 2. That's the same thing as saying times 1/2. Times 1/2. Those mean the same thing as dividing by 2. So when you do 1/2 times 2, that turns into 1x. That's why it cancels. So x equals 14 times 1/2 is 7. The only thing is with matrices, you have to write the inverse in the front. When you multiply regular numbers, it doesn't matter which one comes first. Okay? So these, you just really have to memorize the steps for doing it. Okay.